What do you think? We're trying to solve this, right? What do you think we might want to do first? Good guess. Can I square both sides if it's not isolated? No, so I need to isolate the root first, right? How do I isolate the root? So you don't want me to get rid of the 4? Oh, the 4 is inside the root? Can we not mess with that yet? Okay, so if I divide both sides by 3, what happens to the left-hand side? So square root of x plus 4 equals 3. And now? Oh, now we can. Now we can subtract 4? Oh, not yet? Because it's still inside the root, right? How do I get rid of the root? It's a square root. So in order to get rid of the root, I square it. Square both sides, right? What do I get on the left-hand side? What do I get on the right-hand side? 9. Now can we get rid of the 4? Yeah? X equals? Is it right? Are you positive? How could you be 5? I mean, how could you be positive? Okay, now I heard something that we need to talk about real quick. I heard plus or minus 5. Is 9 minus 4 plus or minus 5? No. Now, I know where that came from, okay? And I'm not mad about it. I know where it came from because anytime we talk about square roots, we suddenly talk about plus or minus, right? But that's when we're taking the square root when we've put the square root inside the problem, right? Who put the square root sign inside the problem? The problem did, right? That's how we got it. Okay? I didn't ever take a square root anywhere. When I take a square root, that's when I have to worry about plus or minus. Okay? So if I really want to be positive, this is the right answer. I want to say 5 plus 4. 9. Okay, good. What's the square root of 9? 3 times 3? Does 9 equal 9? Yeah. I mean, is that such a big deal? Do I really need to worry about checking these? No? Okay, that's fine. All right, let's go look at this problem then. 2 times the square root of x minus 4 plus 5 equals 3. If our first goal is to isolate the root or the radical, what do I do first? Subtract 5. Okay, I'm okay with that. So 2 times the square root of x minus 4 equals negative 2. And then what? Divide both sides by 2. The square root of x minus 4 equals negative 1. Now what? Square both sides. So I get x minus 4 equals 1. Add 5, add 5. X equals? Sorry, I was writing the answer in my head. Sorry, thank you. If I add 4 to both sides, I get 5. Is that the right answer? You're positive. You're wrong. Remember what I said up here on this one? We should plug it in and check it? Because so we could be positive. And I said, is that really that important? And you said no. 5 minus 4. 1. Square root of 1. 1 times 2. 2 plus 5 does not equal 3, does it? Did we do anything wrong except me messing up here at the bottom, but we fixed it? Did we do anything wrong? This is where I need you to look right here. What number can I take the square root of that will give me an answer that is negative? Nothing, right? Nothing. So I could have even gotten here to this part of the problem and stopped without squaring both sides, right? Because I could have said to myself, there's nothing I can take the square root of to get an answer that's negative. And from there, I could have written no solution. As it was, I went ahead and finished the problem because I didn't recognize that. And I got an answer and I plugged it back in and it was wrong. Now, is it possible for you to get the wrong answer because you messed up somewhere? Yes, yes it is. Okay? But is it possible that you get an answer and plug it in and it's wrong and you didn't do anything wrong? Yeah. When that happens, I need you to go back and check your arithmetic. Okay? Checking our arithmetic shows that I didn't do anything wrong. Finding this line right here and putting an arrow to it, that's how I know that what I got as my answer is actually no solution, because there's nothing I can take a square root of that I can get a negative number from. Does that make sense? Any questions about that? So let me ask this question again. When I get an answer, is it important that I plug it in? Oh, yes. Yes, it is. Okay. All right, what about this one? What do we want to do first? Subtract 4, okay? Is that the only thing we could do first for the record? It is not. It's just the smartest thing, okay? If I subtract 4 from both sides, I get 1/2 times the square root of 2x plus 6 equals 8. And then what? Do we divide by a half? Multiply by what? The reciprocal. So multiplying both sides by 2, right? So then I end up with the square root of 2x plus 6 equals 16. Is my square root sign, is my radical, my root, whatever you want to call it, is it isolated now? Yes, right? Nothing's being added, subtracted, multiplied, or divided to the root, right? There's stuff inside, but the root is isolated, yes? So how do I undo the root? If I square it, I have to square both sides, don't I? Don't just say square it, you got to square both sides, yes? So I have 2x plus 6 equals what? 256. And if you didn't know that off the top of your head, it would be very easy to let your calculadora help you. Yes? Subtract 6 from both sides. 2x equals 250. Dividing both sides by 2, x equals 125. Is it right? Should we check it? Oh, yes. Okay. 2 times 125. 250 plus 6. 256. Square root of 256. 16. Half of 16. 8 plus 4. Does 12 equal 12? Any questions? You good so far? Let's see if I can trick you. You gonna let it happen? No? Okay, good. What do I have to do first? Isolate a root, right? I got to isolate a root, so I'm going to do that by dividing by 4. What is this? Are you sure about that? Yeah, I need you to be sure about that. It's a cube root, right? We've talked about it before. I don't know how deep of a conversation. I mean, I know, I don't remember if you know how deep of a conversation we went on it. What does a cube root mean? What times what times what, right? A square root is what times what? Cube root is what times what times what equals that number, right? Okay. How do you think you undo a cube root? Oh, cube both sides. X plus 1 equals. What's the most popular wrong answer today for this right-hand side of this? Do you know? 24. Okay. Is that what it's asking us to do? What's it asking us to do? 8 times 8 times 8. For the record, do I know this off the top of my head? No, I literally just put it in my calculator that's right here beside. See? Minus 1, x equals 511. Is this the right answer? Some people automatically think it's wrong. Why? Because it's big, right? Do we automatically think numbers are wrong just because they're big? No, we don't need to do that. Okay, plug it in to see if it's the right answer. 511 plus 1, 512. Cube root of 512. And if you don't know or don't remember, remember on your calculator you can do cube root with this button right here. Okay, control cube root. You can put a 3 in there of 512. I can't even see that. It's being rude. Hold on. There. Cube root of 512. 8. Don't forget about that. Okay. So 8 times 4. Is it the right answer? See, not only does that help you, like, with your confidence, you also get the right answer, right? Okay. Okay. So I didn't trick you on that one. Let me try it this time. Oh, I'm really going to try to trick you this time. What is that? Would you please get out your exponent foldables? We have talked about this before. It's been a while. Okay? Please get out your exponent foldables. Remember what it looks like? Yes, good. Hold that up, would you please? Good. Once you get it, hold it up so I can see it. Good, good. Excellent, good. Okay, let me see yours real quick. It doesn't matter. Yeah, let me see it. Remember, it looks like something like this. The way you can tell it's the exponent foldable is because it says exponents. Oh. Yeah. Okay. Would you look at power of a product? Would you look at the power of the product? And some of you put some examples on one side and some on the other side. Some of you just did a big line like this one. Would you look at the last example? If you did it 2 sections, it should be the last example on this side. Otherwise, the last example on this side. Okay? See, we did raised to the 1/2 power already. Look at this example and see if you can remember what it means to raise something to the 1/2 power. Thank you. Psst. Thank you. What's it mean? Square root, right? Remember, and if you look at the very back, the very back page, we said if we have a fractional exponent, the top is the power and the bottom is the root. Okay? So if I have a first power, that doesn't change anything, but a second root or a square root is what's happening here, right? So how do I undo a square root? I square it. Now, another way to think about this, which is going to be important on your homework, hint, hint, okay? Another way to think about this is how do I get rid of a fraction to begin with? Where, no matter where it's anywhere, right? How do I get rid of it? Multiply by its reciprocal. Now, I have to keep in mind that while I'm multiplying, this is an exponent, right? So that means I have to raise the exponent to 2 on the other side, yes? Okay. So what happens to this exponent? 2 over 2? So it's 1, so it's just x plus 5. What happens on the right-hand side? What is it? 5. Oh my goodness, a giant number again? I must have done something wrong if I got a giant number. Oh no? Okay, so if I subtract 5 then on both sides, x should equal what? 571. Is that the right answer? 571 plus 5. 576, the square root of 576. Does 24 equal 24? Yes. Okay. Stop freaking out just because it's a quote unquote big number. Okay. Ugh. Sorry, I didn't mean to put a parentheses there. Just ignore that part. So x minus 6 equals the square root of 3x. Is the square root isolated? So what do you want to do? Square? So just like that? Oh, both sides. What happens on the right-hand side? Tell me that. Please take your time. Please take your time and think before you answer this question. What happens on the left-hand side? Oh my gosh, thank you so much. If you put x squared minus or plus 36, you will get it wrong every time. How long have I been saying that to you? Yeah, since August, right? And some people are still writing x squared plus 36 and going on and can't understand why I got the problem wrong. X minus 6 squared is the same as x minus 6 times x minus 6. That's what it means for something to be squared, right? So what do I have to do right here? Distribute x squared minus 6x minus 6x plus 36 equals 3x. If I combine my like terms on the left-hand side of the equation, I get x squared minus 12x plus 36 equals 3x. What type of problem is this now? It's a quadratic, right? And if we're solving quadratics, we need it to equal 0. If I subtract 3x from both sides, I get x squared minus 15x plus 36 equals 0. It's a trinomial with a leading coefficient of 1. So the first thing I want to do or try is what? Yeah, definitely factoring. Okay. So what multiplies to be 36 and adds to be negative 15? 9 and 6 don't multiply to be 36. Okay. So x minus 12 and x minus 3. Zero product property says what? Set them both equal to 0, right? So x equals 12 and x equals 3. Yes? Are they right? Oh, check. Okay. 12 minus 6. 6. Okay, so this side is 6. 3 times 12. 36, the square root of 36? Does 6 equal 6? So 12 is right, so should I just circle them both? Okay. 3 minus 6. Negative 3. 3 times 3? 9 squared of 9. Negative 3 equals 3. No. I got 2 answers. That one doesn't work. I would like you to know what that answer is called. Nope, because it's already there. The symbol is already there, so I can't take the plus or minus. It's just the plus. Okay? This is a solution, right? This thing right here is called an extraneous solution. It's a solution that I got. What does this mean? Extraneous. It's an extra solution that doesn't work. Neus means doesn't work. Not really, I'm just making that up. Okay? An extraneous solution is one that I got. I didn't make any arithmetic errors, did I? No. But when I plugged it back into the very beginning, it doesn't work. So it's called an extraneous solution. Okay? Are there problems that I do all the way through and get 2 answers and they both work? Yes. Is there problems that I do and get 2 answers and neither one of them work? Yeah. Are there problems that I do and I get 4 answers? Like 6 answers? 1 answer? Yeah. Okay. But I'm only going to know if they work or not if what? Plug it in. Okay. And I try to be very clear from almost the very beginning, right? It was our second example that we need to plug our answers in because we don't know for sure if they work or not. Yeah. Now keep in mind, on this one, we don't write no solution. Okay. Because we did get a solution. One of them just didn't work. Does that make sense? Any questions?